Hi guys, welcome to our next session together. So in this session we are going to look at something new when it comes to function, which is the composition of functions. So we are going to learn today how to compose two functions together. So first, let's try to understand exactly what is the goal of this lesson. You see, so one of the things that you should know about maths is that every time when we have objects that reside in a particular space, we are always interested in the question of how can we manufacture new things from the old ones that we have. You see, that's a natural question that you always ask every time when a space has been established. You see that? So one of the things that you should know is that even functions themselves, they are objects themselves in maths. And now having established them and knowing pretty well what kind of objects they are, the next thing that we want to move to is there a way of manufacturing new functions from the old ones that we have? You see that? So there are many ways to manufacture functions using old functions that we have. And the one and the first and foremost thing that one can try to do is just to add them or subtract them. You see that? So functions can be added together, they can be subtracted, they can be multiplied, they can be divided, and all these processes will always result in the creation of new functions. You see. But today we want to look at another nice way of actually creating from of new functions from the old ones, which is known as composition or composing functions. That's what we're going to learn, you see. But now, before we come into that, let's try to understand what composition is all about from the basics. You see that? Suppose we have a function like this one, f of x equal to 3x cubed minus 5 log x. You see that? So let's suppose we have something like this. So one thing that we already have come to understand is that a function is not an equation. You see that? So we know that the x in an equation, it stands for a variable whose value is to be determined. You see that? But for a function, now the x has a different meaning. You see that? So the x that is found in a function, it can be taken as some sort of a receiver. You see that? It is not like like the x in an equation which already has a certain value that it is standing in position of. You see that? The x in a function is not standing in position of a certain value. So there is no specific value that actually is assigned to it. But the x in a function is something which is more like a receiver, which is just waiting for you to put on something and it operates on it. You see that? That's how functions operate. So a typical thing to see exactly how functions do accept things is as follows. So sometimes you can be asked to evaluate things like f of 2 when it comes to function. So first thing you should understand what is f of 2 in relation to the function f of x. You see that? So what this question will be simply asking is, what will be the right hand side of the function evaluate 2 if this x is replaced by this 2 that we see there? So in order to do that, what we normally do is we just go and wherever there is x, we put 2 like that, and then we simplify, which gives us 24 minus 5 log 2, which you can now even use the calculator to simplify. But that's the normal thing that one can do in most cases. You see that? So again, you can put anything there, 3, or you get just, sorry, not 3, but 1, or you just get 3, 1 cubed, minus 5 log 1. And most of the time, logarithms, they're always to base 10 when the base is not shown. So we see that this simplifies just to 3, like that. So this is the role played by this x most of the time. It's always receive. It's always waiting to receive. You see that? So one of the things that you should know is that X is not a thing that can only accept numbers only. You see that? So X can accept letters. You can put A, you can put anything, you can put Y, you can put anything of your choosing. That's what you can do with that X, because it's a receiver, so it's just waiting. So it's more like a box which is just waiting to collect some garbage, and the right-hand side represent on what is going to be done to things that you place into that box. You see? So that's how functions actually deal with things. You see that? So there are times where actually, instead of putting numbers, we put things which are not numbers. So this is now the time to actually define what we mean by the composition of function. So what exactly is the composition of functions? You see that? So composition of functions is feeding functions into functions. So one way of defining what the composition of function really is that it is the feeding of functions into functions. So already in the previous example, you saw that we took a function and we fed inside some numbers and we got out some numbers. You see that? So it is not only the numbers that you can feed into a function. You can also feed another function into another function. But every time when you put another function as an argument to another function, we no longer just call that simply feeding, but we call that the composition of functions. Why it's referred to as the composition of function is because the outcome of that procedure, it always gives out another function compared to what we have seen previously, where we feed a number, you get a number. So when you feed functions onto functions, you get other functions as well. You see that? But one of the things that you should be aware of is that it is not necessarily true that what you get from composition is always a function. Sometimes, yes, you might get things that are not functions at all. But the whole idea is that most of the time when you compose two functions together, you always get functions out. You see that? So when you compose suitable functions together, you always get functions out. So this is one nice way of actually manufacturing new functions. But how exactly is this thing defined, or how is it represented? You see that? So the composition of two functions, say f and g, is denoted by, so the composition of two functions f and g is denoted by f o g, like that. So every time when we want to write down a representation that I'm composing two functions together, this is written using what is called the small o notation, whereby if I want to find the composition of f o and g, is just written as f o g again. You see that? But now one thing that you must pay attention to is that the composition of f followed with g is not equal to the composition of g followed with f. So how also you are composing the functions, the order matters in that particular situation. So it is very important for you to understand all these things. Then the next thing that you want to understand is what is the meaning of that. You see that? So what is the meaning of FOG anyway? You see that? So the meaning of FOG as follows. So FOG of x is this just the same thing as saying f of g of x. You see that? So f or g of x is just f of g of x, meaning this is feeding gx into f of x. So that's what this thing is about. It's all about feeding g of x into f of x. So that's how the composition of functions is defined in most cases. You see that? But one thing that you should know is that the composition of functions is something that is designed to work with two functions, but also you can compose more than two functions. And this is how then we'll define maybe situations where we deal with more than one function at a time. You see that? So given functions f, g, and h, we have that f, o, g, or h is just the same thing as saying f, o, g first, then o, h, or which is equals to f, o, g, o, h, like that. You see, so the composition of three functions is done as follows. You see that? So if you want to compose three functions, you can't do that simultaneously at the same time. So you have to first combine any two successive functions, and then after that, the resulting function is composed with the remaining thing. You see? So this law that we have stated here is called associativity. You see? So the fact that when you are dealing with three things, you can take any two of your choice first, which are successive, is known as associativity. Meaning it doesn't matter which two you first combine in the chain, but the resulting solution will always be the same, like that. You see? So this is how the composition of function is defined in most cases. You see? But then also there is some suitable information that is worth mentioning at this point in time. And this is as follows. So again, we have the following. Notation. So there is some certain notation that you should know by now, like when you are dealing with the composition of functions with themselves. So GOG can actually be, which we know that is just the g of gx, can actually be defined as g squared x. You see that? So this implies also if you have GOG, OG, this can also be defined as g of gx which is actually g cubed x. So this can go on even to n dimension, where you have GOG, OG, O dot dot dot, OG, maybe n times, which can also be written as GN x. So this is very important information that you should know most of the time when it comes to this operation of composition. You see, so this is how it works most of the time. So now what we're gonna do is let's look at examples now on how exactly do we compose functions. So let's start looking at examples on the composition of functions. So the first example that we're gonna look at is as follows. So given f of x to be equal to e to x and g of x equal to 2x minus 1, determine the following. A, FOG, B, GOF. You see, so that's what we want to find now. Given all these, how can we find the following? So solution proceeds as follows. So first thing is A, we want to find FOG. But what is the meaning of this according to the definition? It is the meaning f of g of x, which means in this case g of x is being fed into f. You see that? So which means now what we do is we go to the receiver. Remember, the receiving part of the function is the x itself. So it means that x is going to receive g of x. But what is g of x? Is 2x minus 1. So we get 2x minus 1, like that. Then B again, if I want to find g of f, I know that this is the same as saying g of f of x, which means now f of x is being fed onto g of x. But what is the receiving part of g of x? It is that x. So which means that x is going to receive ex. So we get 2ex minus 1. So this is what you should know. And this is basically how composition of function works in most of the time. You see. So let's look at more examples. So another example goes as follows. Given f(x) is equals to root of x minus 1, gx is equals to ln x, and h of x is equals to x cubed, find f o g o h. You see, so how can we find f o g o h? So you know that for us to find this thing, first I know that f o g o h, I can first compose any two of my choosing. I can compose first g and h, and then later plug into that. So now what is g o h? So g o h, we know that is g of h of x, which means now in this case h of x is going to be fed onto the function g, but the receiving part of g is just that x, so it has to receive h of x. But what is h of x? It's x cubed, so we get ln x cubed, like that. So we can put that. Then the next thing, the FOGOH, which is actually FOGOH, is the same thing as saying function of g of h of x, like that. So which means now the function f is going to receive this composition of g and h, which we have already found. But we know that it also received via x there. So it means it's going to be root of the thing that we have found, which is ln x cubed minus 1, which is the root of 3 ln x minus 1. Like that. Where the simplification now has been done using the laws of logarithms. You see. So, yeah, this is how things work most of the time when you're dealing with composition. So this is how we compose two functions together. You just take another function and use it as an argument to the other function. And this is exactly how things operate, you see. So now what I'm going to do now is I'm just going to give you a nice challenge problem for you to try out. And then I would like to see you posting your solutions on the comment box if you did manage to get the solution to this. So it's just some small challenge problem. So in this problem we have that given that g of x is equals to 1 over x, determine g of 100x. You see, so we now know what is the meaning of this. So we now know that the meaning of this is g o g o g o g o dot dot o g 100 times. So otherwise, thanks for watching, guys. We will meet on our next video where we are going to look at something different again about functions. See you.